we're back at AP Review. This is 2011 AB Free Response 1. For times from 0 to 6 inclusive, a particle is moving along the x-axis. The particle's position, x of t, is not explicitly given. The velocity of the particle is given by this equation, v of t equals 2 sine of the quantity e to the t over 4, all plus a 1. The acceleration of the particle is the derivative of velocity, but they gave it to you because they wanted to be nice. So it's right here, and they give us that x of 0 is 2. So I went ahead and put in my v of t as my y1, and I put in my a of t as y2, because I know I'm probably going to have to use both of them, and it was just worth putting them in the calculator, so this is what I put in right there, right? And it's worth noting what you put them in. Notice that if you're in function mode, which you probably are, you're using x in place of t, but that's fine. All right, so remember, so when you're in function mode, right, x is your t, right? So just noticing that you have to be aware that you're using x is your t for both of the functions. Cool. All right, part A. Is the speed of the particle increasing or decreasing at time t equals 5.5? Give a reason for your answer. Speed increasing and decreasing is literally always about the signs of velocity and acceleration. If the signs of them are the same, like if both velocity and acceleration are positive at that point, or both velocity and acceleration are negative at that point, then the particle's speed is increasing, or you'll hear the colloquial phrase speeding up, right? The particle is speeding up. If the velocity and acceleration have opposite signs at that time, then the particle is slowing down. So either velocity is negative and acceleration is positive, or acceleration is negative and velocity is positive, right? Either of those cases would mean that the speed of the particle is decreasing, or again, the colloquial phrase is slowing down. So our job is just to find v of 5.5 and a of 5.5, and once we do that, we're going to go ahead and look at the signs of those values and then decide whether we're speeding up or slowing down. So the easiest way to do that for me personally, I mean, you don't have to do this, but I already have these in my calculator as y1 and y2. So if I go to table, right, so go to second table set, which is window, and I'm going to start my table at 5.5. I'm really intentionally going to do that because that's the exact value I want. If I then go to second and table, it's going to go ahead and give me both of those values. You'll see that y1 is a negative number, and so is y2, right? So since they're both negative, the speed of the particle is increasing. So I'm going to write that down, right? So I'm going to write that v of 5.5 is negative 0.453, approximately, right? Which is less than 0. And that a of 5.5, which is my y2, is approximately negative 1.359, which is less than 0. So since a of 5.5 and v of 5.5 have the same sign, right? It doesn't even matter which sign, just the same sign. The speed is increasing, right? Now, answer the question the way they asked it. They said, is the speed increasing or decreasing? So answer it the way they said it. They said speed increasing, but if they had said speeding up or slowing down, then you would answer using the phrase that they said. Cool, that's part A. Part B, find the average velocity of the particle for the time period from 0 to 6. So anytime you want the average value of any function, you find it by using the average value formula, right? Inch you this way a little bit. So for part B, the average value of a function is the integral of that function over whatever window you have, divided by the width of that window, right? So 1 over 6 minus 0, the integral from 0 to 6 of v of t dt. And that's what you can write, and then you can type it and get an answer. The AP needs you to communicate that you understand how to do this, and that you understand how to get the answer. They don't care what math you're doing. Now what I'm going to do is I'm going to type a 1/6 function integrate, which is math 9, of the thing I called y1, because I made a note that I called velocity y1, with respect to x, which is standing in for t in this situation, from 0 to 6, and that's what's going to get me this answer that I need, right? So again, I'm going to quit out of here. I'm going to do math 9. Oh, I'm sorry, I forgot my 1/6. So I go back, second insert, in parentheses, 1 divided by 6, parentheses. Okay, I'm going to go to vars. I'm going to go to function and pick y1, comma, with respect to x from 0 to 6, and that'll give me my answer. And I should be looking for a 1.949, which I have, so that's awesome. 1.949, right? The AP wants this. You have to know how to do this, though. Okay. Part C. Find the total distance traveled by the particle from 0 to 6. So here's the cool thing about a calculator section and total distance. If you integrate velocity, you get displacement. But if you integrate speed, you get total distance. So if you're doing things without a calculator, you have to worry about things like when the particle is at rest. But because we have a calculator for this, what I'm going to do to find the total distance from 0 to 6 is I'm going to integrate the speed. And speed is just the absolute value of velocity. So I'm going to integrate from 0 to 6 of the absolute value of v of t dt. And then I'm going to make my calculator do the heavy lifting. That's what the AP is going to need to see. Now, that said, you're going to have to know how to put this in your calculator. So that's going to be math 9, right? I'm going to pick abs. The way you get abs is by going from math to number, and then you'll see it in that list, math and then over to number, of y1, close the parentheses, comma, with respect to x from 0 to 6. That's what I'm going to type in. But the AP just needs to see that you understand that you're integrating the speed. So I'm going to go ahead and hit math 9, right? I'm going to go to math. I'm going to go over to number, and I'm going to pick abs, which is 1. And I'm going to go to vars, over to y-vars, function y1, close the parentheses, comma, with respect to x from 0 to 6, right? Because they said total distance 0 to 6. They did. And then I hit enter, and I should get a 12.573-ish or something. We'll see. It's taken a little bit because it takes a while to integrate an absolute value even for the calculator. There we go, 12.573. So 12.573. All right, cool. Notice that nothing in this problem has had any units, so I shouldn't be surprised that there are no units. But if there are units in a problem, be careful to use them. Part D. For the window from 0 to 6 inclusive, the particle changes directions exactly once. Find the position of this particle at that time. Okay, so this is a multi-layered question, okay? And this is where they're finally going to use that x of 0 is 2. So if I ask you, where were you when you found out where you got into college, right? Or when you found out you got into, pick the college that you were super excited about, the first thing you'd have to think about is when did that happen, right? And then you could answer my question. So what they're asking, first and foremost, is find the time when the particle changes direction. So the first thing that we have to do is we need to find the time when the particle changes direction. But what that means, right? So when the particle changes direction, well, we need to know that that changing direction, right, changes direction, that equates to v of t changes sign. So I can see that by looking at my graph. Now, what's interesting about this is I don't need the a of t in here at all, right? So I'm going to go ahead and turn off my y2 by going to y2 and highlighting the equal sign and then hitting enter, and now it's off. I'm also going to change my window to go from x is 0 to 6, because remember, x is my time here, and I know that I don't need to see past 6, and I only want however many times v crosses the x-axis. So what that's going to look like is v of t changing sign is going to mean crosses the x-axis, which I understand is actually the t-axis technically right now if you're thinking about it that way. But so I'm going to graph, and I'm looking for how many times v crosses this axis, and it should only happen once from 0 to 6. I know that because they told me, yo, it happens once. And there's the one time it crosses. So I'm going to do second calc, and I want to pick 0. So I'm going to scroll over to where that 0 is. Notice that I'm using the right arrow. I want to stay to the left of the 0 because you can see how the instruction says left boundary. So I stay to the left, meaning I'm making sure that my y values are staying positive. I hit enter. Now I need to go to the right, and there's a little arrow that says that in case, like me, you have left-right issues, and that means go ahead and cross to the other side. So I cross to the other side of the axis, hit enter, and then it says guess, and then I just hit enter again, and I'm going to get a value for t. So the first thing I find out is that the time is when t is approximately 5.195 or 6, right? But actually, I'm not even going to approximate it right now. I'm going to write the whole thing out because I'm not done, and that's not the answer they want, ... And I'm going to go ahead and say, you know what? I'm storing that as alpha A, right? I'm going to call that A. So we're going to say, hey, let's call this A. For my records, this thing is A, okay? So the way I do that is I quit second mode, and then since that was the x coordinate, I hit x, and notice that it comes up as that same number, and I store it as alpha A. Cool. So now, that's the first thing, is find the time. The second thing is that they want the position at that time. So I'm going to erase up here. We just need to remember that x of 0 is 2. okay? So finding the position is going to be about using that first fundamental theorem of calculus. Remember that v of t is the same as x prime of t. And remember that if you were to integrate x prime of t from, I don't know, let's say 0 to a, right, using the first fundamental theorem of calculus with respect to t, my bad, using the first fundamental theorem of calculus, you'd get x of a, which is totally the thing I want, minus x of 0, which is totally the thing I know. It's 2. So what I'm going to want to write is x of 0 plus the integral from 0 to a of v of t, right, and I can use that because they gave me that notation, should give me x of that time a. And I was clear to the AP that this is my a, so I can call it a. I don't have to write out the whole thing. So I'm going to go ahead and type this in my calculator, right? This is a 2. This is a 2 plus, I'm going to do function integrate y1 with respect to x from 0 to a. And that's going to give me my answer, right? But again, the AP wants to see this, right? And then they want the answer. So I'm going to go ahead and again, I typed this in my calculator as a. You have to make it clear on the AP that you're calling it a or b or whatever you want to call it, but you have to call it something. If you wanted to avoid a because of the acceleration, you could. I used it a. It's fine. So I'm going to do 2 plus, 2 plus math 9 vars over to y1 in function, right, with respect to x from 0 to the thing I called a and stored in my calculator as a. And I should get this is a 14.134 or 135. So I get that x of that time a is 14.134 or 5, depending on if you round or truncate.